All right, here's your problem of the day. Use graphing calculator or Desmos to graph the function and then describe the transformation. It's a vertical stretch by a factor of 4. Translation 1 unit down. That's a line. Hopefully you recognize that's a line. Next one is an absolute value. Stretch factor by 2, followed by a reflection. Next one is a quadratic, so that's parabola. It's a vertical stretch by a factor of 2, and then translated 7 up. This one is a reflection, 2 units to the right, 2/3 units down. So what we're going to be doing today is we're going to be using quadratic functions to model real-life situations. So this is kind of a how-to or kind of some hints on what we're going to be doing. So if you're given a point and the vertex, you're going to use vertex form. Given a point and the intercepts, you'd use intercept form. And given 3 points, you're going to write and solve a system of 3 equations with 3 variables. So on the first one here, the graph shows a parabolic path of a performer who is shot out of a cannon, where y is the height and x is the horizontal distance traveled. We want to write an equation of that parabola. The performer lands in the net 90 feet from the cannon. And what is the height of the net? So, from the graph, we can see that the vertex is 50, 35, so they're giving us that. And they're also giving us a point of 0, 15. So I would use vertex form. We know a point, which would be your x and your y, 0, 15. We also know the vertex, which would be your h and your k. What we don't know is the a, so we're going to have to solve for a. Do that, and you get negative 0.008. That makes sense that it should be negative because it's opening downward. So now we just write our equation. And we have to find the height when x is 90. So you plug 90 in there. Simplify. And you get 22.2. So the height of the net is about 22 feet. What if the vertex of the parabola is 50, 37.5? So take a second, pause, think about these answers. I'll put the answers up and you can check yourself. All right, on this one, we're given 3 points. A weatherman creates a parabola to predict the temperature tomorrow. So we need to write a function, f, that models the temperature over time. What is the coldest temperature? And what is the average rate of change in temperature over the interval in which it is decreasing, increasing? Okay. So they're asking us to do a couple different things. The hardest part is writing that function. We're given 3 points. And 2 of those points, though, are the intercepts. So that's going to make life a lot easier. So we know x, we know y, that's our ordered pair right there. And we also know p and q are intercepts. Plug everything in. Solve for a. Comes out nice and neat on this one. A is 0.1. So the coldest temperature is going to be in between your intercepts. Remember, that is your axis of symmetry. It's going to be laying on your axis of symmetry, which is your minimum. 4 plus 24 divided by 2, you get 14. Plug that in. And negative 10, which it looks like it matches up to on the graph. So the parabola opens upward. There's an axis of symmetry at x equals 14. So it's decreasing between 0 and 14 and increasing 14 to 24. So the average rate of change when it's decreasing is negative 1.4. For the average rate of change between 14 and 24, it's 1. So that's kind of interesting that the average rate of change at which the temperature decreases from midnight to 2 p.m. is greater than the average rate at which it increases from 2 to midnight. All right. That's all we have at the moment. Hope you enjoy.